Welcome to the Trending XR podcast, where we discuss the latest in augmented reality, virtual reality, and AI with industry leaders who are shaping the future of how we will work, socialize, and go about our daily lives in the third dimension. In the not-so-distant future, we won't even be using phones. We'll be using these. I know, sounds crazy, but we have never been closer to this future concept becoming our current reality. I am so excited to share this new world with you. I hope to teach you, inspire you, and ignite your passion for extended reality. It's time to change dimensions. Are you coming? Welcome back to Trending XR podcast. Today's guest is an absolute wizard. Some would say the final boss of Radiance Field technologies. He has pioneered a pursuit of creating hyper-realistic 3D worlds from standard 2D imaging. He's collaborated with brands and companies like Nvidia and Time Magazine and is a reoccurring speaker at prestigious events such as SIGGRAPH and Nvidia GTC. I would like to welcome on Michael Rubloff.
Hello, hi. Thank you so much for having me on today. I really appreciate being here today.
Yeah, man, I'm stoked for this conversation. So yeah, like the final boss of Gaussian splats. So we spoke about this before, where I've talked to several people about Gaussians and NeRFs and Radiance Fields, and we got really educated on that space and kind of dived into some into the weeds on like digital twins and things with Jonathan Stephans. Sorry, and everyone that I've spoken to is always like, "Well, you got to talk to Michael. He's kind of like he's kind of crushing it in the Radiance Field space."
Thank you.
So if you want to start off by introducing yourself to everyone, giving us kind of a general rundown of what you do and what you got going on for that right now, and go from there.
Yeah, definitely. So my name is Michael Rubloff. I am the founder and managing editor of RadianceFields.com, where I've been trying to both evangelize and centralize all the information surrounding the world of very lifelike 3D through different Radiance Field representations. And so I've been working on and building this out for a little bit over 3 years now at this point. And so I've been able to, really see this technology grow from, the release of Instant NGP, which is kind of like where this radiance field representation began to become available, I would say, to like consumers by and large, to the point where we are now, where just like there's so much interest in the world of radiance field reconstructions with different methods. And we can kind of talk a little bit more about that as we get into the conversation. But basically, my work is to really help provide a centralized platform of information regarding the extremely burgeoning field of radiance fields, and trying to make them accelerate the shift from 2D into a very lifelike 3D world.
Yeah, that so on that, are you working for yourself right now, or are you at a company doing this type of technology work for them?
Yeah, so as of now, I am just doing this, by myself full time. And so I do provide consulting services to businesses that either want to learn more about or experiment with or implement some form of radiance field solution, which is how I am currently sustaining myself. In addition, I do also offer some advertising spaces throughout the website as well, in case people are interested. But no, I am doing this now, full time and, by myself, and with the goal of really just trying to help accelerate the world of this research and translating it into its actual industry adoption.
Yeah, and on that note, for working for yourself in consulting, you also do some speaking roles. I've seen you've spoken at a few pretty notable conferences, and then I think coming up here in a week, you'll be doing Nvidia's GTC.
Yes. No, so I've been very fortunate over the last couple of years to, help evangelize the technology in a little bit more public facing role. So I've been able to speak at SIGGRAPH 2023 and SIGGRAPH 2024. I was able to do 2 talks and a panel last year at GTC. And now this year, just, less than a week away, I am going to be doing a 2 talks and a meetup on Monday. So if you're going to be at GTC, definitely come find me and say hi. But yeah, on Thursday of next week, which is just over a week from now, the talk will be focusing on construction visualization. And then the talk on Tuesday, which is a separate one which you'll have to RSVP for, will be a very, very fun demo that I'll be giving of some of the highest fidelity captures that I've ever seen. And it's going to be a really fun walkthrough.
So for people that aren't able to make it to GTC, are they able to watch your speeches afterwards?
Yes, they are. Yeah, there is a you do have to register for Nvidia GTC, but it is a free registration for virtual attendees, and they actually do a pretty great job of making the sessions available pretty soon after, in case you're not able to like watch it, depending on if that session is being streamed live or not. But they
Yep.
make the sessions available to people within, I think, like a week or so of the actual
Oh,
recording. It's pretty
well,
cool.
that's great. I'll be one of those tuning in because I won't be able to attend this year. Next year would be lovely. I'd love to go. Looks really fun.
Yeah, it's a great conference. And so, yeah, I've been definitely very fortunate in that regard to be able to really help speak at some of these conferences. And another one I just was at was called Geo Week 2, which is more exploring a similar thought line about AEC and geospatial applications of Radiance Field based technologies.
Yeah, and I think that's a good segue for you to tell us like your story about like how you got to doing these types of things. So you're going to be doing. You said it. Your speaking role is going to be on the construction visualization, which I think is kind of like a big use case right now in this space for Radiance Fields, as well as synthetic environments for training for like self-driving cars and stuff like that. So like I think it'd be really cool to like hear the backstory of how you got to this point, because I know you've worked in a few different fields before you got to this, which I think is really cool because there's a lot of people out there who do all these different things that aren't in the XR space, and then it's really fun to see them kind of like make this jump over. And I'd love to hear kind of like what inspired you, if there's any like specific recallable events that you're like, yeah, well, this was the thing I saw or the person I met, and that was like it sent me on that trajectory
Yeah.
towards here.
Yeah, no, definitely. So I would say that, as it relates to the journey of Radiance Fields, it definitely started during the pandemic for me, towards the beginning of it. And at that time, I was actually, help starting a fertility company with a completely different industry. And so, but essentially what we were able to do was we were able to cut the cost of treatment by about 40 to 60%. And we would go into these fertility deserts throughout the US because the actual access to care is very interesting in the US. But uh, during that, I was obviously stuck in lockdown, and my roommate at the time kind of showed me the back of his iPhone. I was like, "Oh, there's a LiDAR scanner on the back of this," and my thought was like, "What is a LiDAR scanner?" And basically he was like, "Oh, it's like if you see like a real estate listing, where it's like have the ability to kind of like fly through it. It's kind of like you can use it to create that." And my response back to him was like, "Well, can you scan people?" And he was like, "Well, I don't think that's what it's like meant for. I think you're supposed to use it for like, other things." I was like, "Well, like, does that mean you can't do it?" And so what I started to wonder is, would it be possible to have, photography and imaging leave 2D? And could you be able to reconstruct the world around you in a very lifelike 3D manner? And there wasn't really a lot of documentation for this, and there were even fewer people who were actually trying this on the internet. And so that became like my COVID hobby, is that I would go and I would just, scan and capture everything. But I would really try to prioritize scanning people and either like places in time, be able to try and really figure out, is it possible for me to translate imaging into 3D, a very, very lifelike 3D? And as it turned out with LiDAR, no, I could not do it. I took hundreds upon hundreds of captures, and they were all pretty much terrible and unusable. But they were not so unusable to me that I felt like we were terribly far away from. I just had like an innate feeling that we could be a bit closer to this realization than might feel like. And so basically, I created a pseudonym called the Light Artist. I just added just to LiDAR, and had been posting on Twitter there, and pretty much been trying to convince all my friends that this is a technology that is perhaps worth keeping an eye on. And basically, I had actually had a meeting with one of my friends. We were going to pitch someone about this actual potential use case of LiDAR, where I happened to see a tweet of Instant NGP, which is NVIDIA's instant neurographic primitive. Basically, this is the thing that opened the floodgates to consumer application of Radiance Fields. And legitimately, I turned to my friend and I was like, "We're no longer pitching LiDAR. This is what we're going to be doing from now on. This is the answer. This is able to reconstruct the world in a very lifelike 3D capacity." And from there, actually, that same friend, for better or worse, I actually did not have a PC at the time, and he did. And so I convinced him to lend me his computer for 1 week, which unfortunately for him I ended up keeping for about 10 months afterwards. And I just started teaching myself Instant NGP, trying to figure out like what is the actual best capture practice for all of this. What is the actual ways to do this? Because I can see now it was actually tangible for us to reconstruct the world in a very lifelike way. And there was no documentation on the internet. There was truly nothing. There was like very little, like there's no Discord channels, there's no posts on LinkedIn, there's no tweets about it. This is not this is something where it's like total like ghost town. The one person who actually I had seen who had made some kind of content on this is actually your previous guest, Jonathan Stephans. And so I reached out to Jonathan back then, and I was like, please meet with me. Please, like, let's talk about all of this stuff. Like, I want to, better get a sense of this technology. And so we actually started to become like friends, back then and talk about like what we could do with this technology. And for the first year, it was really experimenting like I was doing with LiDAR, where I was experimenting with people and reconstructing people and moments in time. And through that course of the year, I started to realize like, well, if this can approximate the world in a very lifelike 3D, obviously there are a lot of use cases for photography, and not all of them are memory capture based. There's actually a tremendous amount of industrial and commercial applications of these radiance fields or of lifelike 3D. And so I started to think through about, okay, well, perhaps then if there is this amount of use across the world, it'd be really nice to have some kind of centralized repository and centralized way of information so that some of these things happen sooner than later. And so at first I was still building out this other company, and I decided this is really a job for a professional journalist. I'm going to create a bunch of packages of information and send it out and I'm going to go through all these different publications where I think people might be qualified or interested in talking about this technology. And so I emailed all of them. I tried to make a very curated package, send it to all of them, and legitimately 0 people responded to me. I didn't get a single response back, and I was just like sitting at my computer after a few days, and I was like, you know what? Like, honestly, I can just do this. I don't need to like have, if people are not interested right now, that's okay. I can go and start to create it myself, and hopefully, people will start to see the value and be curious and want to try it for themselves. And what that really spiraled into is at the time it was called neural-radiance-fields.io, my website. At the time, NeRFs were really the dominant radiance field representation. And we'll talk more in a little bit, I'm sure, about like the different radiance field representations. But as more representations such as Gaussian splatting have come out, I have now moved the site over to radiancefields.com to better reflect the topic in which I cover. But basically, it all stems from a very large curiosity of, is it possible to translate imaging into a very lifelike 3D way? And the answer is yes.
Yeah, that was awesome. There's so much that was packed with so much great info. Keywords there are I'm here is like the curiosity. The curiosity of anything is usually what drives anyone in any field. And I think that's such an important part of humanity is being curious. And that's what's going to uncover the next phases of what you guys are doing in radiance field technology. Just constantly being curious, always playing with stuff, having fun, questioning the things that you're doing. Is this the best method? Like LiDAR, you're like, there's something better, and you just ditch the LiDAR and you're going. It has its own uses for other stuff, right? But you found a new purpose for what you do, and it's cool. I'm excited to watch this kind of just continue to evolve as you guys keep playing with it and finding more efficient methods. And it's really interesting to hear you talk about like getting 0 replies back. Because it's like that was like the catalyst that will have built this thing that might not have existed if you got all these responses back. I think life works in really cool and mysterious ways. So it is challenging, but also rewarding to be a pioneer in the space, which to me sounds like you are pioneering in the space of radiance.
Yeah, no, thank you. I appreciate that. Yeah, and if if one of the journalists had gotten back to me, I was like, "Oh, thanks, Michael, for sending this over. It's really interesting. I'll be sure to check it out." I probably would have just left it there, or I don't know. That's true, but like it would have been a consideration for me, but to at least think through, like, okay, well, they've seen it, and we'll see what happens from here. But it has been really validating to see some of these journalists who I emailed them initially now do cover Gaussian splatting. And so it's really nice to actually like see this actual like full circle. It's like, okay, I knew it. I knew this person would be interested eventually in this technology. It just took, it just took a bit longer to get there.
Yeah, I foresee you having quite a few journal or like write-ups in the near future, and a lot more speaking roles. I'll put a bet on it. Yeah. I got $100 on that.
Yeah, thank you. There's some cool articles that will be coming out over the next few weeks that I'm hoping will step up the people who are paying attention to the technology as well. So
Yeah. And that on that note, I wanted to maybe just plug for a second radiancefields.com, go back to that. So like tell us about that community that you built, and like how many people are a part of it now, and what's in that community on that website. And I think there's a Discord attached, and kind of can you paint us the picture of that?
yeah, definitely. So my goal with the website was to create the most centralized platform possible that could cover all aspects of the world of Radiance Field and lifelike 3D, whereby, I have been trying to create industry news where we're staying up to date with everything that's happening from a series of different companies who are using the technology out in the world. I've been trying to cover all of the companies that have been announcing either new funding rounds or new just like products, functionalities, and features that they've been rolling out. I've also been trying to, like you said, create a Discord community whereby people can join, and I've been trying to curate a list of these companies within there and be able to like get the people who work at these companies inside of this Discord too, for people to this way, because there's so many Discord channels. I feel like it's just easier when everything is centralized. But as you were mentioning too, I also have a job board as well where I've been trying to curate all the different positions for people who are interested in, working on Radiance Fields. I've been trying to compile all of them. I think there's about like 120 different jobs in there right now. And I've also begun doing recruiting services too. So if you are someone who wants to be considered for a role in the future, or perhaps one that's in stealth mode, or perhaps one that's just not listed publicly, you can go ahead and upload your PDF of your resume, and we can just communicate directly with some of these companies for placement services. But I've also been trying to curate, a list of platforms, and just, make it easier and filterable to see, okay, I need a local training platform that has like an Unreal Engine, extension. This is something that I've been trying to make it a bit easier, because I still think that it can be quite overwhelming in terms of finding out like what are the actual platforms and players in this space, and like who does what. What is something that each one can't do. This way, we can just start to make it the lower the barrier to entry for more and more people to get into the space. And it's coming soon. I will have more case studies and get different guides about getting started, capture practices, all of these things too. I've actually realized that the website has swung a little bit too technical, and so I'm working on getting it back to more about from where I started as well, about just you know here's pure excitement about the technology, and this is what you can potentially try for yourself.
That's amazing. I'm a huge fan of what you're building. I think that that's something that a lot of people who are kind of specialists in spaces kind of miss, or even like influencers of these big followings, and they're like, but they work in like the XR space. They didn't build this community. There's a really cool thing, like the nature of what you've built is really cool, because you're creating this community where people can come and learn, and build things together within this Discord, and then have opportunities to get jobs from there. So like this is something I've always wanted to create for myself, in the future of trending XR, is to have a Discord where people go in and work on extended reality projects and help each other, and the people who make stuff post it on there, and the best stuff gets posted on in its own page.
Mhm.
And that's basically somewhere where, if people were ever reach out to me and say, hey, do you know a guy that does this? Like, yeah, go to this page, and these are all the people I think are the best people to hire for that. And it's like you create this ecosystem of people who want to join, and they're learning and they're building, and then they're getting a job out of it. And it's this awesome accelerator type system that I think you've built. And I do believe like we're gonna see some pretty interesting stuff come out of your group from radiancefields.com, and your Discord page, of really bright minds who got together and something was created because of that space you created. I think that's like brilliant. I love that.
Yeah, thank you. No, that's my hope. Just to see what I can do to really help accelerate the adoption of this technology, because it's just, in my opinion, it's just the most exciting technology that I can imagine, is really being able to pull imaging into a fundamentally new medium for the entire world, and to be able to actually start to document moments in time in even more fidelity, and letting people experience and explore these captures. I think is just it's definitely something that I am excited about.
Yeah, I think this is a good segue for you to take us into the weeds and really like go out and see some the deep stuff on what you're working on. To educate, if you could, everybody as best as you can on what it is that you do, and the breadth of it and all the different parts of it. And if you'd like to break down what you think is the most interesting, or the most some of the newest things that you're seeing that are at the most promising future outlook, I'd love to just kind of like dive into some of that with you.
Yeah. So would it be helpful then to just give like a history of just different like Radiance Field methods, and like how it's like gotten to where it is now?
Yeah, 0 to 1. I think, yeah, that's a good way to approach.
Okay, cool. So basically, this all started, funnily enough, immediately before the pandemic. So in like mid January of 2020, whereby there were three students, Ben, Matt, and Pertul, all at the University of Berkeley, and basically, they had the initial breakthrough of neural radiance fields, and this was like the first like modern radiance field boom, whereby they were able to reconstruct from a series of standard 2D images a lifelike 3D reconstruction. And it had these things which are called view dependent features, which is basically if like you move your head around a, say, like a pane of glass, or just some reflective object, you expect light to move and react in a specific way. And that's what these view dependent functionalities are, is that the features are view dependent depending on your angle. And so Nerf worked. It was able to reconstruct the world in a very lifelike 3D way. But the original Nerf paper was very slow in terms of its reconstruction time, meaning this would take more than 24 hours. You would literally like kind of hit the begin the train step, and kind of like walk away for the next day or so. Then I would say that caused a immense amount of excitement inside of the research world, and there was follow-up paper after follow-up paper. And there was, I would say, the next big breakthrough for the world of radiance fields came in 2022, which is where I began to see the world of radiance fields, and that was through Nvidia's instant NGP, instant neural graphic primitives, which is a paper and then an actual application that Nvidia released. And basically what that did is it took the original Nerf paper, which remember is taking 24 plus hours to train, and now the Nerfs are beginning to train in a matter of seconds. So the amount of exponential increase that this paper unlocked was legitimately incredible, where I don't think it's fully appreciated yet about like how big of like an impact that this paper will have on like the future of imaging. I guess in the same way that Nerf has as well. But basically, Nvidia was able to just radically decrease the amount of time it took to get a reconstruction, and it also allowed people to start to install locally on their computers, so long as you have a Nvidia GPU, and which is still pretty much the case now. But basically, this opened the floodgates to all of these different applications, where now it's starting to become possible to imagine the foundations of a very, very strong and lifelike 3D, world. But Instant NGP, while it's actually still one of my favorite platforms, and I think that the captures it reproduces are still like some of the most lifelike. There was a lot of curiosity about like how the best way to display or save these files, what the best way to interact with them, as well as the rendering rates. So the standard rendering rate in Instant GP is, I think, around like 10 frames a second, which is obviously quite a bit slow. And there actually are quite a few Nerf methods that allow you to render in real-time rates. So if people say, oh well, I'll get to this in a second, but Nerfs can render in real time. And so anyways, this was still a big consideration, and about in like late, I think April it was in 2023, then we saw the publication of 3D Gaussian splatting. And for people who don't know and think like, oh, Gaussian splatting is a separate technology, these are all, radiance fields mean like NeRF because it has neural radiance fields in the name. The full paper title of Gaussian splatting is 3D Gaussian splatting for real-time radiance field rendering. It is a method to render a radiance field. And basically this paper came out, and for the first like month or two, it didn't seem like very many people cared, to be honest, which is quite kind of interesting because I saw it and I wrote an article like right in like at the beginning of May. And I was like, I just started to wrap my head around like how Nerf works and how it functions. And I saw like Gaussians and I was like, what the heck is this? But there were a lot of really incredible things that the Gaussian splatting does. For one, it features a explicit representation compared to NeRF's implicit one, and it also renders at well above real time rates. So the first Gaussian splatting paper was already pushing 120 plus frames a second, and it's only improved since then. And it also, Gaussian splatting also outputs a, PLY file and uses rasterization, which is a lot more compatible with the traditional graphics pipeline, meaning that you can build on top of it with things like React 3 Fiber and 3JS and other like modern web libraries. And so it became a lot easier to figure out, what do we do with this technology? How do we start to actually implement it? And so that's why I've been trying to say now, like, Gaussian splatting is the first bridge to industry adoption of radiance field representations, but NeRFs and Gaussians are not the only two radiance field representations that exist. They are currently the two most popular. There's actually quite a growing number of radiance field representations that are all coming out over the last like couple of years or so, and on an ongoing basis to this day. And when we take a look at like when we talk about like, oh, this is a hot area of research, like there are legitimately 5 to 10 papers a day that are coming out about radiance fields right now. And it's just like,
Wow.
It's such an active area of research that I feel like is relatively unappreciated compared to, say, video models or LLMs. But there is such substantial interest in this world. And so basically, fast forwarding a little bit, what kind of like seemed like slingshot Gaussian splatting into the forefront and onto everyone's mind is, it won best paper at SIGGRAPH at 2023. And it seemed like from that day on, there was just like so much interest and so many questions. I think that's when people started to really, see it and, actually understand. And at the same time, too, they began to put out the actual paper and the code for it. And from, what I've understood, the code is already just like so nice and easy to understand that it's easy to get things up and running for this technology. And people have been very quick to implement and build on top of it and use it for various purposes and functionalities.
Yeah, thank you. That was an excellent, I guess, explanation, kind of like where things started and where they're at now. Because that's wild, like 5 to 10 papers a day, and if we backtrack to our earlier part of our conversation, when you got started in this, just 5 years ago, you said you couldn't even find a video on this, right? You couldn't find anything on this in terms of information. Um, for education, and now you got 5 to 10 papers a day. That's like that's like an awesome acceleration of the information and people that are working on it. That's where like this, I think, a huge the real big innovations are going to happen probably in the next couple of years in this space, because so many people who are really bright are now working on it. And thanks to you, that has probably grown from starting the things that you have. Um, I think that's a great a couple of great points that you made in there, is to kind of maybe like it's really kind of cementing in me that like what you guys are working on is, so like I've always talked about the holy trinity for XR, which is you got your hardware, and then you have the data capture and packaging, depackaging side of things, and compute, with like edge and stuff, and then you've got like the creators who are building the experiences. That's kind of like the three parts of XR, main parts. And it's, the more I talk about this with experts like you and Jonathan, is that this might be the most important piece of the puzzle. And everything's important, but this is what's going to, I think, allow for the vision that we have for extended reality, for all these really uh, immersive experiences with real world 3D environments, and being able to quickly capture things and then enter into them and use them as games or as educational things or personal entertainment, whatever it might be, et cetera, et cetera. And everything's going to be built on what you guys are building now. This is kind of the thing that's going to make all of the ideas that we're going to have able to be made. It's what it seems like. Um, the trajectory of it feels that's what it feels like to me.
Yeah, yeah, and it's something that, I really want to help, like, prod people's imagination in terms of and across, like, a diverse set of industries and applications, whereby it's just like, it wouldn't make sense for me to try and say like, "Oh, here are all the use cases of this technology," if I think this technology is an imaging medium. The amount of use cases and applications of that is so staggering, but it's so personalized, and being able to actually, like, see, like, what is actually valuable for someone. And sometimes, you just need someone to say like, "Oh, this is possible in this industry. We could use it in this way for our industry." And, being able to begin this like, imagination, like domino effect, I think has been something that I've been really trying to work on, and, be able to let people start to explore and think through like, "Oh, it'd be great, if we could visualize our construction sites as if we were actually there," or it'd be great if we could begin to actually layer on additional, artificial intelligence on top of those captures to get better business intelligence, or, use it for simulation-based purposes. There are all these use cases that
Yeah.
have fairly been like explored. It's actually like kind of exciting in like how much opportunity that there is when you start to think through like, we can start to reinterpret how we interact with the world now in a very lifelike 3D capacity, and the amount of like marketing
Yeah.
applications is really really exciting. I'm looking forward to that over the next couple of years.
Yeah, and that's kind of a good segue into talking about like why this instead of traditional methods, and specifically for XR. If we're going to be visualizing these things in VR headsets or in AR glasses in the near future, what that means for like compute, and why radiance field technologies are the reason that this is going to be possible in terms of reducing the need for like heavy compute onboard hardware, because that's kind of, I think, a big part, and correct me if I'm wrong, from what I understand about this technology, in a lot of capacities, is that it reduces the file size of like, you know, 3D environments, because you're going from having to have this really dense, heavy mesh that's big, like a huge file, takes forever to load and to process as you're moving through it, to these kind of like interpretations of what something's supposed to look like based on a sparse set of images.
Yeah, so there's so many like exciting things about the world of radiance fields, and I think one thing I should like back up to like start to say is that radiance fields, whether they're like NeRFs or Gaussian splatting, or ray trace based ones, they essentially take in 2D data, so either standard images or video, anything that can capture a still image. Any type of camera can reconstruct a radiance field, or can provide the data to reconstruct a radiance field. And what gets really exciting about this technology is that it's a bit more forgiving than, say, like photogrammetry, in terms of the pure number of images that you would need to use to get a solid reconstruction. And so, like you mentioned, the actual like data set size, the underlying data itself, typically can be a bit lighter than traditional photogrammetry methods too. And I was really scaling this out to say like the size of like a construction site, or some, large scale aerial surveying. The actual cost savings on, from like, say, like an AWS perspective, is, ends up being quite substantial. But you're also now able to, like you mentioned, to get pretty small and compact file sizes too. And it's also, I would say, like a testament to like the world of research. So to give Gaussian splatting as an example, when Gaussian splatting first came out, um, it was not uncommon at all for there to be a file size exceeding a gigabyte, that resulting PLY, where the capture itself was, say, maybe like just a individual object, or just like a small room. They were really large file sizes. And since then, there's been enough research success in the last year where that's now been cut down to, I'd say its end capture size now is like 15 to 20 megabytes or so. And the amount of compression that's gone into that has just been like awesome. And it's not even like they're saying at this point, okay, we've compressed at 95%, this is where we're maxed out. That's not the case. And, we're still going to get smaller and smaller here. And so you get these resulting very lightweight white file sizes. And on the Nerf side, the Nerfs actually have the capability of being compressed to sub megabyte now, which is very crazy. And this is also just like another very active area of compression too. So it's just like these file sizes are getting really small, but with the side of Gaussian splatting, for instance, you're able to get them to be running in real time on the browser, and there's a lot of more. There's a lot easier way to distribute this representation right now.
I got you. All right. So beyond just the technologies needing to have less data heavy 3D models, you also have advancements in compression technology.
Yeah,
helping out.
That's true. Yeah, exactly. And like, there's just, I would say that on the research side, everything is being like researched right now. So it's just like there's so much technological improvement that's happening. So CVPR, which is a very large computer vision conference, that just released its accepted papers list like a week or two ago. And now we're starting to see, like, just this week, a lot of these papers get like published or publicized. And so another big area of research is these like surface reconstruction, and being able to get like meshes out of these different radiance field representations, which is just remains to be a very hot area of research, as everyone wants to see. Because radiance fields natively do not produce meshes; they do not create polygons, and
Right.
There's been a lot of quests to go like do the reverse of like, okay, how do we start to pull cleaner and cleaner mesh approximations. And there's also been a tremendous amount of success in that regard. There's been some really exciting papers just this week that have come out, kind of highlighting this.
Yeah, and for people who are watching this who are like traditional 3D artists or whatever, can you explain maybe brief or in layman's terms for them of like what it means to have this like 3D environment, but there's no actual 3D mesh?
Um,
Or even what do you had mentioned there's no
Yeah. So basically, it's just like it's all, so Gaussian splatting is all like point based, for instance. So that there's no there's just no mesh. There's no polygons. It does not create any polygons throughout. So it's just all these essentially like individual Gaussians. Where if you're familiar, say with like Jackson Pollock, for instance, like as the painter, where it's just like if he's like either dripping or throwing like paint onto a 2D canvas, you kind of like imagine it in the same way, where like Gaussian splatting is kind of like if Jackson Pollock was just a computer, and instead of creating abstract art, he was this Jackson Pollock equivalent was able to produce very lifelike representations from a given viewing angle. And if you could imagine him just painting a different canvas for every different viewing angle and having it match up with like the real one. That's more so like how Gaussian splatting works, but at no point does it create a mesh natively.
So yeah, I guess like what is the data that is a part of a Gaussian splat? Like what's being stored and then what's being portrayed? If it's not polygons or meshes, what is it that is being I guess
Yeah.
created?
Yeah, so basically it's just like these in the case of 3D Gaussian splatting, it are these essential like they're almost like 3D ellipsoids, where you have like, it's almost like a football of different of all different shapes and orientations and sizes. And like that last example, basically you take, because you're using rasterization, you take these 3D Gaussians, and then you literally like splat them onto this 2D canvas, and that is the way that we interact with it on our viewing screens. And so depending on that viewing direction, you are going to see a different part of the Gaussian, which is also partially what causes some of the issues with like popping. If you ever notice, as you move around and rotate the scene, there's kind of this flickering effect. And that has been a big area of research too, and it's also, I think, partially what's prompted some of the world of research into ray trace based approaches. But there's also a
Right.
really exciting NVIDIA paper called 3D Gaussian Unscented Transform, which basically brings ray trace based effects to rasterization, which is pretty wild. And that solves. There's also one called like hybrid transparency and Gaussian spotting. There's also solves this, and there's one called Stop the Pop that also solves this. And
And that.
yeah, they're all really great papers that I think should be implemented into any Gaussian spotting, implementation. But on the unscented transform side, NVIDIA has said that they will open source that code at some point, and I am looking forward to that because I think it will also really help with the fidelity of captures.
Yeah, I've seen that you posted quite a few times over the last couple of weeks on some pretty big advancements in terms of like the fidelity and quality of these technologies. That we went from something that had a lot of this popping or like ghosting. If you have like
Mhm.
part of the image is not, it's like kind of blurry. I don't know what you call that.
Just like artifacts.
Artifacting, yeah, but that's like heavily reduced, and I don't know how. If you want to explain like anything that you've seen recently that's kind of made that a far more crisp image set
Mhm.
or video, a 3D experience, I would love to hear about it.
Yeah, so I mean, there have been, so many great research papers that have really helped push forward the reconstruction capabilities of these methods. I think my favorite one from the last year or so, or last year, was this paper called Bilateral Guided Radiance Field Processing, which got ported into Nerf Studio specifically on their Gaussian splatting capability. And what that does is it makes the captures even more forgiving from the input data. So like if you have a lot of variant exposure data, say like some images are a little bit overexposed or some are a little like underexposed, it now begins to like decouple the exposure from this reconstruction process, and you're able to bring back so much more detail into the actual resulting scene. And I found that that paper alone makes a massive difference. Um, on the other side too, there's also been a lot of generative work. So we kind of like haven't really touched upon this yet, but like in addition to reconstructing the real world, radiance fields can also be generated as well. And there's a lot of research going into like how do we create, say we have a room and we forget to capture one like section of it, and we're like, obviously there's a giant hole now in this place. There are some methods now that start to, essentially ingest the other input images and then start to in paint. And you can use this to like fill in the gap of like, okay, we didn't get this little area here, but we can use generative AI to help us. And there's another really interesting
Yeah,
video paper called Diff 3D Plus, I believe is what's called. And that is, I think, currently like this the state of the art on the generative side for like detail preservation. And yeah, there's one paper too, I forget what it's called, from Google, but basically if you're capturing a person, which is in my opinion the hardest thing to capture from a single device, um, people move a lot, which obviously creates inconsistencies for these reconstructions, and they will reconstruct what they see from a given angle. This paper from Google essentially allows you to retroactively change the pose of someone in a given 2D image, and you could say like align it to like a reference image. If you're like, okay, this is the image that I want to use as the 3D reconstruction, it will align all the other viewing angles to replicate that one, and then use that to train the reconstruction. And it it seems like it works. It's kind of
pretty
wild,
cool.
but yeah, there's um there's a lot more. Oh, I guess to answer your question actually too, in terms of like some of like these other methods, is that some of them are just take different either like sampling strategies in terms of like understanding like what's in the given scene. And I think that a very large difference is also from this initial step, which is called structure from motion, which is more of a photogrammetry technique. And basically you are aligning cameras in a given 3D space, and this has a massive impact on your reconstruction fidelity. So the more accurate that you can get your camera poses, and you really understand to a very granular level where the camera was in a given space, This also tremendously helps too. And like, the de facto for most people is using a library called Colmap, which is great. Uh, there's been a lot of advancements in some other methods too, as well as like now, say with like using reality capture, who has shifted their license to be a lot more permissive to everyday users. People are getting really. This is also making a really big impact for people who are really starting to like fine tune that initial structure for motion data before they go and train the Radiance Field.
Yeah, so there's a few things there that you're kind of hinting on the like a multi-camera setup, right? Which would be, I guess, more ideal for something like this for um, a better understanding of different angles, so it's able to put together like this 3D scene more effectively. If you have more camera angles than not, but we also talked about at one point in a previous conversation about kind of reducing to one, which is this like back towards that generative AI type part of the conversation where we're able to take this one image or just a couple images and build out this whole 3D scene without this like big camera array or tons and tons of image capture. And it seems like that's kind of maybe the trajectory that we're going in.
Yeah, no, I think that that's definitely likely. And on the camera side, it's just like I was mentioning earlier, when like humans move a lot, and depending on how much data you're able to ingest in a given moment, like if you have more views, that's just less views you have to capture at some point in that during that process. And it's like if you're outside, say capturing an outdoor capture, like you'll have the clouds moving in the sky, for instance. And so the faster you can create that capture, it just to your benefit, because there's less chance of some variable, happening in that given moment of capturing. So the more devices you can use, the better. But you really only need one. You don't need to, even if you're just using like your smartphone, you can get really excellent captures from that. Um, and yeah, and then on the other side, like you were mentioning, for like say like going down to a single image or some of these other like video models and diffusion models. But yeah, we've started to see some companies like World Labs and Odyssey begin to show some of this capabilities, which has been really exciting. So one of the co-founders of World Labs is Ben Mildenhall, who is the one of the co first authors of Nerf, and it's probably a lot of this is attributed to his work and his research over the last like 6 years about where we are now. And so they've been making a lot of really incredible progress, it seems like, in the world of like 3D world generation from say a single image. And then, there's also companies like Odyssey, which is really specializing in say like lifelike, you know, uh 3D reconstruction from generative. And they're actually going to be showing something at GDC next week. So I'm not sure what that will be, but I'm definitely excited to see see more what they've been building.
Yeah, I think Genie One's another one.
Mhm.
Google's kind of world generation thing. Yeah, I think that stuff's pretty wild.
Yeah.
Because that's kind of like getting into like the ability to generatively create whatever you want to play a game. That starts getting into like the future of films and kind of like media experiences people are gonna have. Where you could just like type up like the movie idea you want, and it will just generate this world that you can kind of like just experience based off a prompt, or like a single image, yeah. It's really cool with what's going on in the space. I'm pretty excited to see what happens in 2025, which is, like, I think a great starter for, maybe you to tell us what you think are, like, the best applications, for what you like, for Radiance fields that you're seeing out there right now, whether it be for synthetic data for training, self-driving cars or what it might be.
Yeah, exactly. So one of the big ways it's being used right now is for training, autonomous vehicles, where you have companies like Wave and Applied Intuition and AI Motive. And yesterday, actually last night, I saw there's an article about Wabi, which is a like a tracking company, started to publish results of some of their simulations of. They did not say what's powering in the case of Wabi, powering their simulator, but that's on my list of things to find out if they're also using Radiance fields. But in the case of the former ones that I named, all of them are using some form of Radiance field, where whereby Wave, for instance, they have two different simulators. They have Ghost Gym, which is powered by NeRFs and other like neural rendering, and then they have another model called Prism, which is a dynamic Gaussian splatting simulator, whereby they can start to simulate the world around them. And then you have Neural Sim from Applied Intuition, which is another Gaussian splatting based simulator. And basically, what they do and I'll also say that, sorry, just before I dive into that, that
Good.
there are other, autonomous vehicle companies like Waymo has been listing quite a few jobs for Radiance Field engineers over the last few weeks, in addition to Zoox, which is like a autonomous taxi company, has also been hiring a lot of Radiance Field engineers. But basically, the way that they've been using this technology is that they have, their cars that are driving in the real world, and these cars are capturing a lot of data in 2D. In this case, we'll say images. Um, and basically, what they are doing is they are taking these 2D images and they're reconstructing very large radiance fields on the size of, say, a city. And at this point, too, it's important to say that like radiance fields are able to scale infinitely to the point where if you have enough images and enough compute, you can reconstruct a city or a country, or any random size that you're able to afford. Um, but they're taking these reconstructions and they're saying, rather than, sim or driving and trying to interact with, say, the most long tail and random chance encounter in the physical world, what if we were able to simulate that moment infinitely over and over again in a virtual one? This way, we're not having to put people in danger. We're not going to incur like the cost of traffic accidents or all these things, but we can simulate it and we can actually get the ability to start to feel more confident in exposing these models to these very long tail scenarios. And that's what they're using these radiance fields for. So they're creating, these reconstructions, and they're creating infinite simulations about um, about the different conditions that you might experience on the road. And what they've found is that it's, in the case of Wave, it sounds like that they've had a lot of great success with this too. And I would say that like it also has, well, I don't know if I can say this directly, but like in CES this year, Nvidia announced a world foundation model called Cosmos, which is geared towards the generation of physical AI. And one of the examples that you see most often from the generative outputs of Cosmos are driving cams. And I believe that, a lot of this mentality is thinking like, we can also, in addition to creating real world data sets from 2D images, we can also generate them and use that to also reconstruct the world into a radiance field that we can thereby run simulations on. So I think that like from that perspective, it's definitely one of the big areas that radiance fields has been getting used in the real world. Another way that it's happening already is if you take a look at Google Maps on your phone, there are certain listings depending on the city in which you are living or exploring it, where they have something called immersive view. And immersive view gives you a preview, like it kind of implies, of that given location. They have both immersive view for exteriors and immersive view for interiors. In this case, radiance fields occupy the interior version of Google Maps immersive view. So if you are, say, looking for a restaurant, a bar, a coffee shop or something, depending on your city, you might see that little immersive view tag, and it kind of will like fly you through, do a little like fly through of the website of the location. And depending on the way that you're interacting with it, from what I can understand, before you click in, it definitely looks like it's a Nerf to me. It looks like it probably is like Smurf, which stands for Streamable Memory Efficient Radiance Fields, which is a Google research paper. When you click into it, it is now Gaussian based to allow people to, I think, be able to move around and render in real time rates, which is now being used. Essentially, they are using this method called RadSplat. And RadSplat is a very interesting paper because when people like to pit, oh, like Nerfs are dead or Gaussians are better, or vice versa, like Nerfs look better than Gaussians. This RadSplat actually is a hybrid version. So what they do is they train a Nerf, and then they use that trained Nerf to then train a Gaussian. And from that, you're able to get the realism of a Nerf, and you're able to get incredibly high frame rates on the reconstruction, where in their paper they're publishing something like 700 frames a second that they're pulling out of their Radiance Field implementation, which is awesome. And so if you're using Google Maps, I definitely suggest, and if you see it in the future, these are Radiance Fields representations.
Which is kind of a level up from what they were doing before, which is just traditional photogrammetry with like Matterport, right? I think that was the original like scanning system that they had for interior spaces.
Yeah, yeah, and so it's definitely a big step up now because it's no longer saying like, okay, you could stand here, or you could stand here, or you could stand here. These Radiance Fields give you complete and total autonomy to move through a given space as if you are actually, you can just walk around it. And so you
Yeah.
can imagine then like the use cases of comparing it to a Matterport scan in like real estate, for instance, or
Yeah.
anything that you're trying to document as like a moment in time and giving people the actual ability to explore. And this is why I get so excited about the technology is that, if this is going to represent as an actual underlying image medium, the amount of use cases will, in my opinion, follow the same that we have in 2D and photos and videos. So it's
Yeah.
pretty near limitless.
Yeah, it's like we have the culmination of a few just really powerful technologies that are just slamming down on the accelerator button for everything else around it. With AI and stuff like with Radiance Fields, and it's allowing, and this is, I mean, so what it's allowing for in the Google sense for going inside the space is, previously you have to do that, like you jump around from spot to spot, right? And that's like the photogrammetry scan. So with the Gaussians, or is it what was the specific term for it that they're using? It's
It's
the
just like
mixture.
Radiance Fields, I would say. Just which one?
They're mixing NeRFs
Oh,
and
RadSplat is that
RadSplat.
method. Yeah.
Yeah, so in this in RadSplat, you're able to kind of just move around freely as if you're like walking in a game. Is that kind of how it works? It's not just like
Typically,
jumping effect.
Google limits like your path in terms of having like a linear fly through, and you can kind of like scroll around and look in all directions from there. They don't give you
Yeah,
total autonomy, but like that isn't like an artificial limit introduced by Google in this way, whereas
sure.
this is
In the future may not exist, and I think that's like it's gonna be a really interesting way to like just jump through. Like I think like virtual stores is gonna maybe have an like its thing in the future here, where it's like just really up to date. Like you got a couple camera in your store, a couple cameras, and it's just like updating a live like product like on the shelves, and you could just go in virtually and click on a product and buy it and have it shipped to you. I think it's plausible, with this type of tech,
yeah.
which is pretty cool.
Yeah, yeah, because it's just like, you can reconstruct anything that's located in the physical world, and so it's like if you have like say like a Nike store or some like activation in a retail environment, once it occurs in the real world, or it doesn't even need to get that far, but if you did want it to be an experience for people in the real world, you can just capture, take a bunch of images, and then you can bring that into the actual, digital and VR and AR environment for people to explore who can't physically be there. And so I think it's a way for people to get way closer to these, either these companies or moments in time, or say in the case of like a museum, there's all these like use cases where it's just like there, in my opinion, is room for a lot more improvement in terms of people's interactivity and being able to like create these meaningful experiences for people. And I think that the way that this can happen is in a very lifelike 3D capacity.
Yeah, I'm pretty excited for that. They've already kind of seen some pretty awesome uh, experiences built for like museums and seeing things that, in places where you just can't go to, or it's expensive to travel. So you can go jump into that space and get educated and check things out. And,
Yeah.
it's nice to be able to previs things too. So say you want to go on this trip and spend money and do this thing. It's like, it's nice to be able to go and have these like rich 3D experiences there first, to be like, okay, I do really want to go
Right.
and check that out in person.
And like being in Manhattan, for instance, sometimes it's like, okay, like today I want to go work from a coffee shop or something, but like, do they actually have seating? Like where can I actually like, is there a place for me to work in this space? Or it's just like, if it's like an important like dinner or date or something, it's like I can, start to actually see like, okay, like this is like actually where like I want to be. And you can start to get a bit more personalized with like your experiences. And in the case of museums, what I think is also really interesting is that most museums only show roughly about like 4% of their collection at a given time, and that the rest, is not available to the public. And I think that like this represents a really compelling way to open up like a museum's catalog to the general public and allow them to learn and like understand and get a better picture of what the collection entails. Because one of the things that we haven't really touched on yet is that while it's possible to reconstruct this world in life like 3D, you can also do a lot more on top of it. Meaning, like, say in the case of a museum, and you want to start to just be able to let people explore like a painting or a sculpture, which is great. You get to walk around, you can see it, but you can start to layer in more levels of education, whereby you can put spatial audio, you can put different annotations, you can put other animations and environments and other things within this, whereby you can really start to step up the immersion capabilities of this technology. It kind of just like layers on top of itself. And then we can also start to talk about just general education as a medium too. Now it's like you're expanding it out of museums as a use case and just general education. There's a lot of things that you can do with this technology, where I just think that has been so under explored to this point.
Yeah, and I'm seeing it kind of it's really starting to expand a bit, and I love seeing that there's a lot of young kids getting into it, which is a very important part of the growth of this sector, is that the young kids are getting into this and studying it and building things. And I've seen kind of like a big expanse in that regard, which is I think great. The more, if you're watching this, if you're young, man, start getting into it now and start building. It's really, there's just so much out there for just innovation and the ability to kind of just put an idea out there and this brand new experience that we're all having in extended reality. There's just a million different fields. And like you could do education or museums, you can do Radiance Fields, or you can do hardware for AR or VR. It's like there's so many applications and jobs out there that are gonna just open up to everybody. And I'm super excited for it because I'm a big AR guy. I'm really looking forward to the release of AR glasses for everyday life and all the different use cases for that. That's my primary interest and focus.
Yeah, no, I am too, and it's really cool on the side of like the like glasses hardware. Snap has introduced V5 of their spectacles, which they do have agreements with Scaniverse, which is Niantic's like 3D Gaussian splat
Yeah.
equivalent.
Hey,
So
well,
yeah, and so you can start to actually like interact with like say some of these captures inside of these devices too, as you're just going about like your day, or if they're targeted activations and such. And one note, as we're talking about Niantic, is that just this morning, I don't know if you saw, they announced the sale of pretty much of quite a lot of their business, with one of the main exceptions being Scaniverse, and with this expectation of we're going to build Niantic Spatial now, and it sounds like Scaniverse is going to become very central to the core business of Niantic, and I think it's a good indicator about like the direction and the excitement level of this technology, where some of these very large corporations are starting to pivot. I mean, in this case, literally like pivot to this technology and this world. And it would not surprise me if Niantic announces some very exciting things in the next week.
yeah, we kind of touched on that with Jonathan in the regard of Scaniverse, and like there's this future. There's there's probably going to be like I don't know if they'll have a program for this or not, but it'd be cool if they paid people to go out and scan the world. You're already out there. If you can make $5-10, like, hey, you'll need scans of this space. If you have enough people that go and scan it, you just have this wide array of people scanning their environment, and then we can basically move our world into the third dimension much faster. If everybody is doing scanning, which is it's really cool. It's like the hive mentality of like producing scans.
Yeah, no, exactly. And it's something that like in the medium term, I'm interested to see like on the hardware side from capturing devices too, like how they evolve. I have a feeling that we might see a somewhat revised camera design in like the medium term too. And we see things like the X-Grid scanner, for instance, which is, like if you walk around with it, a lot of people are not sure what you're holding. But like I think that this is something that we'll see more and more often, is that like we're going to start to see more hardware that's really tuned to create these lifelike reconstructions. And
Yeah.
yeah, I think it's just going to accelerate from here.
Yeah, that opens up that whole when we hit AR at mass adoption, it's like what happens to phones and do phones just kind of evolve into something that's more useful for the AR experience. And it's like something that's got, they exchange out cameras for like beefier like LiDAR hardware or something that's gonna you'll be able to scan if necessary, to enrich your 3D experience with your AR glasses. Early on there's gonna be a lot of, evolutions of this how we interact with our environment and connectivity and data crunching. It's you got a small headset, so you got to offload probably some of that hardware to a compute puck. Do phones become more of compute pucks than this like thing we interact with every day? It's going to be interesting to see how things evolve. All right, so I went on your LinkedIn and I was going through some of your content. You have some awesome stuff on there. If you guys want to get some really great content on Radiance Fields, I highly recommend that you go over to his LinkedIn page and check out some of his posts. But you had a specific post on, it was a video on was it sparse voxel grids? That's new to me. And I was curious if you could kind of maybe explain what that is and why it's interesting.
Yeah, so basically, yeah, so you have something called like sparse voxels rasterization, or SV raster, which is a pretty new paper from Nvidia. And what it is it's another Radiance Field representation. So it's just like how we have like NeRFs and Gaussian splatting and some ray tracing based approaches, this is another one of these. But what's really interesting too in this is that it uses rasterization, which is what Gaussian splatting uses, but like it also does not contain any Gaussians. It basically is kind of like a Minecraft based approach, where you have literally like these like voxels that are occupying the space, that are still producing these view dependent effects that I mentioned earlier, whereby reflections are modeled correctly, things look like they do in the real world. And they have some really nice benefits to this, where the frame rates are in real time. You don't have these popping effects that you would get from Gaussian splatting, for instance. And there's a lot of really nice functionality that comes with this this method. And this is part of why I've been trying to evangelize and say that like we should be talking about like the technology as a whole, in terms of saying like these are all Radiance Field representations, as opposed to saying like just focusing only on like this is like the one true version of this technology. So we don't know yet what the final version of this technology will be, and it's just a very active area of research. And so it's just exciting to see a continuing of more novel Radiance Field representations come out. The closest one to this actually is a paper called Planoxels, which I think came out around like 2022 or 2023. And that also was a Radiance Field method without a neural network. A fun fact about that paper is that one of the authors is one of the co-founders of Luma Ai. And so that's been like kind of like a fun fact about like, okay, like, what is this Luma built on? But basically the main point is that like there's a lot more Radiance Field representations to come than just NeRFs and Gaussians. And I think that it's overwhelmingly likely that we will see a continual process for this as these research papers and methods come out. Another really interesting paper that came out recently is called Radiant Foam, whereby they are, it's another novel Radiance Field representation. And it also, has the advantage of being, fully differentiable, creating different ray trace based Radiance fields, so that you are getting, the full ray trace experience. But they're able to have it render and run at like 200 frames a second, for instance. And this can be done on any device. So you don't need to necessarily stay within the Nvidia ecosystem. For instance, with Radiant Foam, this is something that will work on any modern architecture or GPU or CPU. And so there is a lot of potential improvements still to be made throughout the world of lifelike 3D. And so I would just keep paying attention to the different Radiance Field representations. They're all going to get significantly more capable. It's not to say that NeRFs have an explicit ceiling, or Gaussian splatting has only so far it can go. I really don't think this is the case. All I'm trying to say is that there are so many Radiance Field representations right now, and there's going to be more to come too. So we should, I think, still keep an open mind about what the world of lifelike 3D might hold for us in the somewhat short to medium term.
Yeah. And for the viewers, if you find this really interesting and inspiring, the best place for you to check this stuff out is at radiancefields.com. Join their Discord. And also, you have a podcast called View Dependent.
Yes, that's right. And so I've been very fortunate from that podcast to be able to talk to some of the leading, engineers that have been working in this world of research over the last year or so. And so if you've been, that podcast is a little bit more technical in nature, but there's some really fun stories that are contained throughout them, and kind of like how we got to this point and where things might be heading as well. So I definitely suggest that people are interested. All of the videos will be on YouTube in addition to any of your like standard podcasting platforms. So definitely check them out there. But ideally, I would recommend checking them out on YouTube, because there are some videos that we put into them.
And in closing, I always ask every guest if they have a app or a book recommendation, or maybe a website or something that you think for the viewers who are getting into Radiance Fields and the like, that might really help accelerate them. And maybe if you have a few that are like maybe for beginners and maybe for people who are more advanced.
Definitely. So I would say that the one that I'd recommend, so when I first bought a camera, I bought it and I didn't know how to take any images yet. So I went to like websites like Flickr to see like how people were actually like shooting, what the camera settings they use, how did they get this resulting image? And because it felt very intimidating to me at that time. And one of the platforms I think has done a great job in terms of lowering the barrier to intimidation for Radiance Fields is SuperSplat, which is a platform created by Play Canvas, where they just released SuperSplat 2.0, where you can now have a great gallery in terms of all these like community source captures. You kind of like fly it through and kind of get like a better sense as to like these captures and what to do with them. You can edit them too. So I would definitely suggest that people who are wanting to just like kind of experiment or like see something for themselves, check out SuperSplat. It's really a great platform that is getting so much attention, and really exciting work is being pushed. It seems like multiple times a week to their platform, and they seem to be they're very responsive on customer feedback too. So I definitely would suggest checking them out. In terms of also getting started, depending on what your hardware is like, if you have a Nvidia RTX GPU, there are some really great options, which I'll go into in a second. But say if you have like a phone, or you're on Mac, I would check out some of the cloud-based platforms like Luma or Polycam are two great potential ones where you kind of just like drag and drop data sets and just like get going with there. If you want to step things up a little bit and you have a Nvidia GPU, it's really great to use is a platform called PostShot from a company called Jawset. And it's right now, it is currently free. We'll have to see what that is like in the next, they've been in a beta for, a long time. And I think it might be coming to a close in the somewhat near future. But I definitely recommend, installing them. It's a one-click download for Windows. And then if you are a bit more technically minded or have a bit more experience, I still believe the highest fidelity captures that you can get are coming from a platform called Nerf Studio. And that one you will need to pull from its GitHub repository. Jonathan Stephans actually does have a couple tutorials on how to build Nerf Studio. It's really, it's not I would still recommend giving it a try. I have an article about like a command guide in terms of you literally just copy and paste the code, but you are able to get very high fidelity reconstructions out of Nerf Studio.
Well, yeah, thank you. Those are all really great recommendations, Michael. And I wanted to thank you again for coming on and sharing such a wide breadth of knowledge with everybody. I think we got a little bit of everything. We got some starter info, and we got some really detailed stuff. And I hope that this has kind of inspired some people into the Radiance Field technologies, and it gained some more followers in your Discord channel, and you guys create some interesting stuff there together. Again, thank you for coming on and giving us your time, and I look forward to bringing you on in a subsequent podcast to talk to you about the advancements that will happen from here.
Yeah, no, thank you so much for having me, and yeah, really appreciate the interest in the technology too. So I'm hoping that, like, it's just gonna accelerate from here. This is the worst it's ever gonna look like. So it's an exciting time.
Yeah, well, thanks again, man. I appreciate you coming on. We'll catch you on the next one.